Hello guys, and welcome back to Coding the Conway's Game of Life in Ruby. In the previous video I have once again given you a small task, small homework to try to finish implementing each of the 4 rules which govern the behavior of the cells within a game of life. Hopefully you knew how to do that. But there are many like hidden traps and issues that may arise while doing that. So I thought I would just try to explain the process more. So here is my tick method here within this main file, and here are each of the 4 rules, and hopefully somewhere along writing the code yourself you have written something like this. Okay, you have this first rule we have implemented in the last video, and here is rule number 2, which says that if cell is alive and if that cell has 2 or 3 live neighbors, then that cell is survives the round. And I have introduced this new method called revive ! Which basically, if we look at it, is opposite of die ! It just makes a cell alive. Okay, and let's jump back to the top to see our tick method. So that's rule number 2. Rule number 3 says that if cell is alive and if the number of live neighbors around that cell is greater than 3, that cell should be dead in the next round. And rule number 4 states that if our cell is dead and it has exactly 3 live neighbors, that cell should be alive in the next round. So these are the 4 rules, but this isn't correctly written, okay? And I will show you exactly why. But first off, let us check our specs, which we have written here. So I have written, these are all the specs on the right, which I have written. There are a lot of them, so let's go through each and every one of them. I have written an additional spec to describe rule number 1, stating that it should kill a live cell with no neighbors. Okay, so let's jump to our spec real quick, and let us run just this test under line 128. So our specs blah 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 128. We see that it's passing. So far so good. Let's jump to our second test, which we have written before, stating that it should kill a live cell with 1 live neighbor. So that's underline 135. And we see that that test is passing. Okay, let's jump on to the next one, 142. Doesn't kill live cell with 2 live neighbors. Okay, since rule 1 states that it kills with fewer than 2, then it shouldn't kill a live cell with 2 neighbors. Let's see what happens here. 142. We can see that this test is failing, and this may be tricky to figure out why. On the surface, we have specified everything correctly. We initialize a new game object with 3 seed cells in here, and the coordinates are 0, 1, 1, 1, and 2, 1. And I have drawn a sketch once more to see which cells we have seeded the world with. And those 3 cells are this dark gray cells, which you can see here on the sketch. And now you see that we tick the game over, and now say that this cell right in the middle of our grid should be alive, since that cell has 2 live neighbors. But according to our spec, that cell is dead. So we have to figure out what is happening here. And what is happening is this. Because we have written our tick method as we did, and we iterate over each and every cell, and then we immediately change the state of that cell according to its current number of neighbors. And what that means is this. First off, we iterate through this cell, and then we iterate through this cell, and then through this, and then through this, and then through this, etc. And when we are looking at this cell, we see that it has fewer than 2 live neighbors, meaning 1, and we immediately kill it. Okay, and by the time we iterate through this one and through this one, and by the time we get on observing this cell right now has 1 live neighbor, and we also kill it, and then we also kill this cell. And this is not a proper behavior of a game of life. A proper behavior should be something like this. When we observe this cell, we see that it has 1 live neighbor, and we somehow have to store its alive or dead state in a temporary array, which will become relevant in the next round. We do not have to kill it right away, we just have to kill it in the next round. Okay, so what we have to do here is we have to do something like this. I will just uncomment the real code, the proper code, which makes it all behave well and good. So what I have done here is, I will run you through it. What I have done here, observe just these lines. Okay, under rule number 1, what I've done is this. I haven't changed the wording of a rule, so it's still if cell is alive and if it has less than 2 live neighbors. Then I have introduced these 2 temporary arrays, one specifying next round live cells and one specifying next round dead cells. And what I'm doing here under rule number 1 is I'm moving that cell into a array consisting of cells which should be dead on next round, not immediately turned dead. And this causes the game to behave properly. And I have done the same with each and every rule. So as you can see, within rule number 2, I store a cell in an array consisting of live cells which should be present in the next round, and the same in rule number 3 and rule number 4. And at the end of a tick method, I iterate through each and every cell within both arrays, meaning within an array specifying next round live cells and with an array specifying next round dead cells, and then make these cells alive or dead. Okay, and what happens is when I run the so right now, upon introducing these 2 temporary arrays, hopefully you understand how we have made the game behave properly. Let me just explain one more time, just for clarity's sake. When we look at this cell doesn't immediately turn dead. It kind of remembers, okay, I have to become dead on the next round, and it becomes dead exactly when we iterate through each and every cell. When we come here and when we have no more cells to iterate through, then all these cells change their state, okay, according to the rules which govern them. Okay, so let's just go through our specs here real quick to see what I've done here. So within the context of rule number 2, stating that any live cell with 2 or 3 live neighbors lives on to the next generation, specify that it should keep a live cell with 2 neighbors to the next generation, which is pretty kind of similar to this test right up here. And you can see that I seeded with 3 cells, which are these 3 cells, and I check if they are properly dead or alive in the next ticking of a game. In the next test, I test that it should keep alive a cell with 3 neighbors to the next generation, and here I populated 4 with 4 cells, and then check their states. And basically I do the same with each and every following spec. So within a context of a rule number 3, I state that it should kill a live cell with more than 3 live neighbors, and then I do the same, and then on rule number 4 I do the same. So this is, I think, basically it, basically everything before we go on to visualization I'm sorry, with the Gosu gaming library. Right now we have the whole game working properly as it should. Okay, we have some ways. Actually, we have a number of ways to improve our code, but we won't worry with that right now. We just worry that our game is working properly. So if we run all our tests, we see that all our tests are green, and we see that our game is behaving properly, and we are very happy right now. And we will stop this video because it's quite long, and in the next video we will begin implementing the visualization with the Gosu gaming library. So see you guys in the next video.